Hi everyone, and welcome to our video on probability and the standard deck of cards. So the deck of cards is something that they usually expect you to know in probability. So if you've never seen cards before, I'm going to show you the way that to create the sample space. Okay, so with our deck of cards, I'm going to start it with 2. So number-wise, it starts with 2. So we'll do 2, 3, 4, 5, 6, 7, 8, 9, and 10. So those are the numbered cards, we would say. So let me mark this up above. So these are the numbered cards, because if we had an actual deck of cards, and maybe I could look one up real quick, at least for images, these would be the cards that have actual numbers on them. And then after the numbered cards, there are face cards, which involve the jack, the queen, and the king. Okay, so let me just put that up there. So J is equal to jack, Q is equal to queen, and then K is equal to king. Okay, so that's what those mean. And again, if we had an actual deck in our possession, these would have faces on them. So it's the faces of these like kind of royalty type people. Okay, so these are the face cards. And then after that, there's one other card, and that's the ace. So it's not a face card, it's not a numbered card, it's its own thing. In different games, it has different values to it. So for instance, maybe you know blackjack or the game 21, you might say, well, don't aces have a number value of 1 or 11? Well, yeah, in that game they do, but still the actual card itself does not have a number on it, and it does not have a face on it. Okay, so let me see if I can just get one. I should have maybe looked this up before. Okay, but it's taking a couple seconds. Okay, so here we go. So we've got our standard deck of cards. Boom. Okay, so right. Like this is one of them. Okay, so they ordered it in a different way too. So they put the ace first, and then the numbered cards, and then the face cards. Okay, so notice the face cards have a weird kind of royalty type thing. I know it's kind of small, but and then the aces are just A with whatever symbols on it. Okay, and so those other symbols are the other important thing about the cards. Okay, so there they are so far categorized: numbered cards, face cards, and an ace. And then, well, there's going to be 4 suits. So for this, I'm just going to say, hey, how about we state that these are the clubs. Okay, so I'm going to put that right there, the clubs. And the clubs look like a clover. So that's the clubs. And then after the clubs, and this kind of goes in no order, so it's not like one suit's better than the other, except again in maybe some games one suit might be better. Okay, but anyway, we've got clubs, and then there are the spades. The spades kind of look like a shovel or something. Like the end of a shovel. I don't know. There we go, something like that. So those are the spades, and it has the same 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace setup. Okay, and then after that, so these would be the cards that are black. So these are the black cards. And then after that, I'm going to go ahead and use red. So after that, there are red cards. There are the hearts, which again have these same cards to them: 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. And the hearts, well, that does look like a heart on those little cards that you get. There we go. There's a heart, the symbol. And then after that, there are the diamonds. Okay, so 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the jack, queen, king, and ace of diamonds. Okay, and the diamond looks like a rhombus or a diamond. There we go. Okay, and these are the red cards. Okay, so these are called the suits. So there's 4 suits. there's 3 different variety of cards, either numbered, face, or ace, and then there's 2 colors. Okay, overall though, so inside of this box, I guess, if I want to put a box here, I'm going to lightly try to do it without going over anything. So these 52 cards would be the total sample size. So the number in our sample is 52. Notice that each suit has 13 cards to it. The numbered cards, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbered cards. Okay, or per suit there are 3 face cards per suit and 1 ace per suit. Okay, so either way though, so for now we will just kind of draw 1 card. So well shuffled deck means it's going to be random, so we don't know what's going to come up from us when we draw a card. Okay, and again, if you've never seen cards before, you Google it, kind of like what I did in the middle of this video. But this at least again gives us the sample space, so you could visually see it. So there's 52 elements in the whole sample space. All right, but I think we could try to use this for these problems. Okay, so it says a card is randomly drawn from a well shuffled deck. Find the probability of the problem. Find the probability of the following. Okay, so the probability of drawing a 4. Well, in my sample space, I see there are 4 4s. Okay, so these ones right here. And I think I'll erase these highlights too, but just for this right now, there they are. Those are the 4 4s. So I have 4 4s out of a total 52 cards. And then from there, it would reduce to be 1 out of 13. Okay, so there they are. And let me again just kind of erase that. Just wanted to show it for this problem. But I think when it's nice enough, we can use the same table multiple times. Okay, for number 2, drawing a red 4. Okay, so I'm just using my probability notation. So the probability of drawing a red 4, well, there are 2 of them. Right there, I see them. Okay, again, just to highlight them real quick, and then I'll erase the highlight. There's the 2 4s that are red. And so I have 2 out of 52 total cards. And then, well, that reduces to be 1 out of 26. All right, that's it. Okay, so again, this is how nice it is to see the sample space. It's just counting. All right, so on number 3, drawing a 5 or let's box that, or a jack. Okay, so the probability of a 5 or a jack. Okay, so again, I'm going to highlight, but erase my highlight. There's 4 5s right here. There's those. And then there's 4 jacks. Let me go ahead and use a different color. There they are. Or, remember, the union symbol means to just count anything that's marked. Okay, so I've marked 8 different things out of a total 52. And then from there, we would reduce it. It would reduce to 2/13. And I'm not doing any of the work showing the reduction. Often you could use calculators and we could reduce it from there. You are just still, I guess, just to show it for this problem. So like divide by 4 would have given us that. And then over here, divide by 4 would have given us that. Okay, so I'm just doing the quick reduction. Okay, and then number 4, drawing a red card or an ace. Okay, so as soon as you see a keyword, you want to box that up. Okay, so red card or an ace. Well, let me go ahead and erase my 8 marks from before. Okay, so this is what's nice about the computer, where I can erase things like this if you need to. I mean, you could resketch this out if it got too messy for the rest of the problems, but I'm just going to keep using and recycling what I wrote above. Okay, so drawing a red card or an ace. Okay, so drawing a red card, well, that's half of the deck so far. And so even here, let me just highlight red, because I know it's split between the two. I know there's 26 red cards. Okay, so I have so far, well, but maybe, oh, hold on. Actually, there's 2 different ways we can do it. Let me unhighlight that. Let me go ahead and highlight all of these. Okay, so I'm just gonna highlight in a line, actually. Okay, so I'm gonna change my strategy. Okay, so there's all of the red cards highlighted. And then it says or an ace. Let me highlight that in a different color. Here are my aces right here. Okay, so this is why I wanted to change my strategy, because I want to just go to counting with what I marked. So anything that is marked, so red or an ace. Well, I currently have marked all of these yellows would add up to 26. These pink, though, are part of the yellow, so kind of this bottom half is 26, and then I have two more, 27, 28. So that's just using counting out of a total 52. And then from there, we could divide by 4 again, and it would give us 7/13. Okay, so that's one way to look at it. Okay, another way to look at it is using the union rule. So the probability of a red or an ace is the probability of red plus the probability of drawing an ace minus where they have an intersection. Okay, so this still needs some knowledge of the cards, and I'm going to keep the same highlighting that went in there. Okay, so just to write the left side again. So the reason that this might be helpful is here I'm just looking at the red cards. Well, we said half the deck is red, so there's 26 out of 52 that are red. And then there are 4 aces from the deck, so 4 out of 52 are aces. And then minus where they have a common overlapping. So the highlighter still shows that. Where the pink and the yellow overlap, there are 2 cards. So I would minus 2 out of the 52. And then, well, when this simplifies, it is 28 out of 52, or eventually 7 out of 13. So it's the same answer. Okay, so it's just 2 different ways to go about it. So like say you're taking a test, you might want to do both ways, especially if you finish with plenty of time. Okay, so that's using those cards there. Okay, so let's keep going with it. We've got a couple others. Drawing a club or a face card. Okay, so I see or again. Okay, so drawing a club. So the probability of a club or a face. So just abbreviating, let me fix how I wrote club. Okay, so club or face. Okay, so the or, again, I could use the union rule or I could try to count. Okay, so going back up. Okay, so this is where, again, my highlighter, I could just erase this real quick. Okay, so there's the blank one. Like I said, we could re-sketch this out every time as needed. Okay, so we are looking, and here's what's a little trouble with this video. I have to do is scroll a little bit. So club or a face card. Okay, so the clubs, here they are. There they all are. And then or a face card. Let's do that in pink. So our face cards are these ones here. Okay, and so the way that I could use this method right now is I could just count anything that's marked because of or. And we could go through it and say, well, I currently have 13 marked in this line, in this first line, and then I have 9 others that are marked kind of below it. Okay, so I have 13 plus 9 then, and you could even show that, the 13 plus 9 just like that out of 52, which gives us 22 out of 52. These are divisible by 2, so 11 out of 26. So that's using the counting method. But either way, I mean, I think using the highlighter would be good. If I want to use the union rule, let's go ahead and abbreviate a little bit, would be the probability of getting a club plus the probability of getting a face card minus the probability where they overlap. Okay, so the probability of a club, well, there's 13 out of the 52 are clubs. The face cards, there are 12, so 3, 6, 9, 12 total face cards. So 12 out of the 52 are face cards. Minus the probability where they overlap. So again, the highlighter helps. I can see 3 where it overlaps with the yellow and the pink. So there's 3 out of 52 for our overlap. And then, well, again, if we do this subtraction or addition and then subtraction, we'd have 22 out of 52, which gives us the same thing. Okay, so just showing that I could check it. Okay, so kind of either way, I would say use the visual. Okay, and then number 6, drawing a heart or an even numbered card. Okay, so like before, I see or. Let's go ahead and set it up. Probability of a heart or an even numbered card. Okay, so heart or even. All right, and I'm going to use the erase again. Okay, you can see, so if I didn't erase this, I think it would get too messy for every single problem. So if I really wanted to kind of waste your time, I guess I could draw this out every time for each of these, but I think it's nice to do this to save a little time. Okay, anyway, so I want the heart or even. So my hearts, I've got 13 of those. So I'm highlighting it. And then my even numbered cards. Okay, so even are these four, these four, these four, these four, and these four. Okay, so this time let's just go to the union rule. I mean, we could count all of them and do it that way. I'll leave that up to you if you want to check it. But let's go ahead and just use the union rule for this one. This one might be a little bit better for it. Okay, so the probability of heart plus the probability of an even minus the probability of a heart and an even. And then so I want to plug those in. So the probability of a heart, well, that's all 13 that were in the yellow highlighted out of the 52. Plus the probability of an even numbered card. So that's all of the pink highlight. So I've got 4, 8, 12, 16, 20 out of 52. Minus the probability where the highlights overlap. So I've got 1, 2, 3, 4, 5 overlapping elements. So 5 out of 52 would get subtracted. Okay, and then from there we would want to do our simplifying. It becomes 28 out of 52. And then from there we can reduce that. It is 7 out of 13. Okay, each were divisible by 4. Okay, so there we go. So that one I'm using the union rule first. Again, if you want to count all of these, you could. I guess just in words, we could have said, all right, there's 4, 8, 12, 16, 20 numbered cards. Some of the reds, or not, some of the hearts were already counted. So 20, and then, well, looking at the 3 would be 21. 5 is 22. Then 23, 24, 25, 26, 27, 28. Okay, so that still gives us the same probability. Okay, so one more time here. Okay, so here's where the complement rule can help. So not drawing a numbered card. So the probability of, I'm going to write numbered with the apostrophe not, would be the same as 1 minus the probability of drawing a numbered card. Okay, so we'll just set it up. Okay, so the probability of drawing a numbered card. Okay, so let me use my erasers so this is no longer in the way. If it will let me. There we go. Okay, so blank. Well, the numbered cards, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4. So I have 36 numbered cards. Okay, so I have 36 numbered cards out of 52. And then from there, again, we could use our calculator. Without a calculator, we just need to get a common denominator. And that would give us 16 out of 52. But that reduces, they're each divisible by 4. And it gives us 4 out of 13. So that's the probability that we draw some random non-numbered card. Okay, so the majority are numbered cards. The other way we could have looked at it is, well, I don't want numbered cards. I could count these to the right of 10. Okay, so there's 1, 2, 3, 4, and then 4 suits. 4 times 4 is 16. That was what we got when we did the subtraction. 16 out of 52. Okay, one other, drawing a face card and a heart. Okay, so the and, this is the probability of a face and a heart. We are drawing just a single card. So another way that they might say this, since it's and, okay, so and with one card is a little weird to say, but we would be saying a face card that is a heart. Okay, so face card that is a heart is another way to look at that and a different way to say it. Okay, so it's where the two would overlap. So a face card that is a heart is where they overlap. So a face card that is a heart is, well, here's my heart. Face card that is a heart are those three right there. Face card that is a heart. Okay, so that's it. So we had 3 out of 52, and then that does not reduce. 3 out of 52, that's it. Notice the aces are not counted in that. Face cards, aces don't have faces on them. Okay, so there they are. I guess the other way we could have done this is look at all the face cards and the hearts. Just real quick, here's all the face cards. Here are all the hearts. And it's, well, where do they overlap? Well, it's those same 3 that we just did real quickly. Okay, so either way, it's 3 out of 52. Okay, so the thing with this is, again, if you could see the sample space, I think it makes things a lot easier for you with these problems. So draw it out. It really helps. It doesn't take too long. Yeah, it gets annoying to write it out multiple times, and even erasing stuff is nice. If you do it, say you have this on a test, it might be good to write this out like in ink, and then use your a pencil to help you with the rest of it, so that way you could erase and lightly do the pencil. So that way you don't have to do it every single time, kind of like what I did with erasing it after every problem. Okay, either way, there's usually multiple ways to try it, though, like we did on some of them. Okay, so you've got your options. Okay, anyway, thanks for watching, and if you do have questions, let me know, and I'll see you again soon.